Okay, so as we've mentioned, there are many ways to solve equations, like finding the values of the variables that result in the equation being true. One of the algebraic methods that we've seen is to use inverse operations to undo what has been done with the variable. Other sub-methods involve writing equivalent expressions and manipulating the equation with the properties of equality. Today, we will see how to solve equations by using graphs primarily created on a calculator. So consider the equation 3x minus 2 equals 10 minus x. So solve this equation by using standard methods and then showing it's a solution by checking. So if I have 3x minus 2 equals 10 minus x, we're going to solve for x. So add x to both sides. 4x minus 2 equals 10. Add 2. 4x equals 12. Divide by 4, so x equals 3. Then using your calculator, fill out the table below for the two expressions. Circle the solution you found in A. So we're going to use Desmos for this. So I'm going to show you how you would find this in Desmos. So what I did on Desmos is I went ahead and typed in y equals 3x minus 2. And then do you see that little gear at the top, almost to the left? I clicked that until it went to a table option, and then I typed in to make sure it went from 0 to 4 like I need in this table on our problem. So when x is 0, y is negative 2. When x is 1, y is 1. When x is 2, y is 4. When x is 3, y is 7. And when x is 4, y is 10. And I'm going to do that same thing for the other equation in Desmos. So now I typed in y equals 10 minus x, and then again I used the little gear at the top left and turned it into a table, and then typed in 3 and 4 to show 0 through 4. So for this one, when x is 0, y is 10. When x is 1, y is 9. When x is 2, y is 8. When x is 3, y is 7. And when x is 4, y is 6. So what you are looking at here is using a calculator, sketch a graph of the two lines. So y equals 3x minus 2 and y equals 10 minus x on the axes. So and then use your calculator to find their intersection point. So I'm going to show you what that looks like on Desmos again. So what I did first is I typed in the two equations, y equals 3x minus 2 and y equals 10 minus x, to show where they intersect. Then I used the little wrench up in the top right corner, and I changed where the x-axis goes from negative 2 to 6 and y goes from negative 2 to 11, and I'm going to press the wrench again to get rid of that window. So by doing so, I now have this screen, and if I tap the little dot, it tells me where they cross. So if I'm going to quickly sketch this on my graph here, I'm going to use red for the red one, and it starts at negative 2 and it goes up by 3 each time. And then the blue one starts at 10 and it goes down at a less steep rate. And then where it crosses is at 3, 7. So fill in the blanks. To solve the equation f of x equals g of x. Sorry, I'm going to start that over. To solve the equation f of x equals g of x, you graph both f of x and g of x, and then find the intersection point or points of their graphs. So we're looking at the x values. So this is one of, if not the most important equation solving technique. It literally works for all equations, although it will not always result in exact answers. We can even solve equations that don't yet have algebraic techniques for. So consider the equation x squared minus 11 equals negative 2x plus 4. We will eventually have multiple algebraic methods for solving this quadratic equation, quadratic because it's x squared, but for now we'll solve it graphically. Solve this equation graphically using a window of negative 8 is less than or equal to x is less than or equal to 8, and when y is between negative 20 and 20. Show that your answers are solutions by checking the equation. So I have two equations here. The first equation, sorry, I need to use my pen. The first equation is y equals x squared minus 11. That's our first equation. And our second equation is y equals negative 2x plus 4. So I'm going to type both of these into Desmos, and I'm going to use the window that they suggest, and I will input that here now. All right, so I'm going to label these real quick. So the green one is actually this one, and the purple one, which I need to find a purple real quick. There we go, there's a purple, maybe. Turns out I need to figure out how to use this. Ew. So this one's the purple one. So if I were to sketch that real quick, looks like the purple is a negative that goes approximately like this, and the green looks like this. And then it says, show that your answers are solutions by checking the equation. So I'm going to look at where it crosses. So if you look at where these cross, they cross at negative 5, 14, and again at 3, negative 2. So it says to show that they are part of the equation. So what you are doing is you are plugging those in for x and y in the original equations. So in the original equation is 14 equal to negative 5 squared minus 11. So is 14 equal to 25 minus 11? Yes, 14 is equal to 14. We did that one correctly. The next one, I'm going to use a different color, is negative 2 equal to 3 squared minus 11. So is negative 2 equal to 9 minus 11? Yes, negative 2 is equal to negative 2. And then you can do the same thing for the other equation, but it will work. So there you go. So it's important that we're able to take a graph and use it to help us solve an equation. So let's take a look at the next exercise, which works with an absolute value equation, which we've done some of this year. So this function is shown on the grid below. Use it to help answering the following questions. So find all values of x that solve the equation shown below. Circle points on the graph to illustrate your answer. So this equals 0, that's your y value. So where y is, wow, that's a really terrible way to write value, but good thing you're listening, right? So that's where x or y equals 0. So where y equals 0 is right here and right here. So when y equals 0, x is negative 1, 2, 3, 4, 5. And when y equals 0, x is 3. So this next one is saying when y is negative 2. So we find when y is negative 2, that's right here and right here. When y is negative 2, x is negative 4, and x is 2. Find all values of x that solve the equation shown below. This will necessitate a bit more work on your part. Verify the values of x that you found are in fact solutions to this equation. Show the steps in your check. So it's saying that y has to equal x minus 1 because of this right here. That's what y equals. So look at this. What is your m of that equation? It's 1. Your slope is 1. What is your b? It's negative 1. So we're going to graph this up on this. So we start at negative 1 because that's my b, and my slope is up 1 over 1. And because we already have the v graph is already the 2 times, sorry, I was interrupted. So the 2 times absolute value of x plus 1 minus 8 is already the v equation. So the other equation that we just graphed was y equals x minus 1. So now we need to find what are the x values at these. So this x value is 1, 2, 3, 4, 5. And this x value is negative 3. So we need to check these to see if they work. So is 2 times the absolute value of negative 3 plus 1 minus 8 equal to negative 3 minus 1. So 2 times the absolute value of negative 2 minus 8, is that equal to negative 4? Well, the absolute value of 2 is 2, so 2 times 2 minus 8, is that equal to negative 4? Well, yes, 4 minus 8 equals negative 4. If you were to do the check for 5, it would also show that it worked. Our last one. The functions y equals negative x squared plus 4x and y equals 4 minus x are already graphed on the grid shown. Which of the following sets gives all solutions to the equation of those two being equal to each other? So we need to find, okay, where do they cross? Well, this point is at 1, 3, and this point is at 4, 0. So what are the x's in those? Well, the x is 1, the x is 4, so the one that has 1 and 4 as the x is going to be 2. So there you are. We're going to be doing some more practice of this in class, so if you don't get it now, don't be frustrated. You'll get it eventually.